Now it is the debugging time. So what we are going to do is to perform interesting in debugging practice to see the previous pre-bridge mode. What you are looking at is TRACE32 debugging program, and this is the instruction window with the address and then assembly instruction. This is the register window in the RISC-V architecture. As you can see, the set of general purpose registers are displayed. And here is interesting information that indicate the current, the pre-bridge mode. This kind of information is not available when you look at any of the source code, but since TRACE32 is hardware debugger, this show you the current pre-bridge mode. The current pre-bridge mode is user mode. Please take a look at this. I will do the right click over this value and a small pop-up display. User mode, HS mode. The HS mode is identical to the supervisor mode. And here is the machine mode. The M mode stands for machine mode. I can change this icon. Please take a look at this. I just switched the pre-bridge mode as the supervisor mode. After I change this icon, you can see this address start with SP. So let me move back to the original, the pre-bridge mode. Now it's the user mode. Please take a look at this. Address start with UP. This means the current pre-bridge mode is the user mode instead of supervisor mode. Now let's change the current pre-bridge mode as machine mode. 1, 2, 3. Please take a look at this. Now we are in the machine mode. So the TRACE32 debugger allows and any of the observation of pre-bridge mode, current pre-bridge mode. Now we will go back to original pre-bridge mode, that is user mode, the user mode. Then another observation will be the value of MPP bit field inside machine status register. And because this bit field lets you know about previous pre-bridge mode. For this, we have to navigate the menu inside TRACE32 debugger. And please take a look at this. I will choose the CPU, then move to the preparer. The new window appears to show the current, the several important control and status register. And control and status register is one of the most important interface register, lets you know the current status of RISC-V processor. You can see the several items. Among them, I will choose this one, machine trap setup. And inside this option, the first CSR register you are looking at is machine status register. Machine status register has the different bit field such as SIE and MIE, but among them, MPP bit field indicate the previous pre-bridge mode. So I will dive into more about the MPP bit field inside M status register. MPP stands for machine previous pre-bridge mode. This bit field is located the 11 to 12 bit inside machine status register. If the previous privilege mode is user mode, this bit field is updated to 0, 0. This is in the binary format instead of hexadecimal format. If the previous privilege mode was the machine mode, this bit field is updated to 1, 1. Remember that this value is in the binary format. Now what we are going to do is to perform the e-core assembly instruction to see how this value is updated, MPP bit field. Let's take a look at the value of MPP bit field inside machine status register. Now this bit field has the user value. So I will modify the value of MPP as supervisor, and this indicates that the privilege mode was supervisor mode. The reason I modify this value is to let you know that the value of MPP field is exactly changed when I run this e-core assembly instruction. So I will arrange this window to show you how the privilege mode is actually changed. Now I will run this assembly instruction. That is a DDI assembly instruction. I will click the step icon. Now a 7 register is updated to 0x40. And before the e-core assembly instruction, we can see that A7 register is updated because in the Linux-based environment, the system call number is updated using A7 register. That is one of the calling convention in RISC-V architecture. Now, without further ado, so let's run e-core assembly instruction. Before running this instruction, I want to say to you, please pay attention to this icon, also this icon. So let me go with 1, 2, 3. Great. Please take a look at this. MPP field is updated to user. Reason is previous privilege mode was user mode. At the same time, this icon is updated to machine mode because current privilege mode is machine mode. For better understanding, so I will revert this instruction by using r.undo. Please take a look at this. r.undo command. This command is supported by TRACE32 debugger to revert this assembly instruction. Okay, I will enter. Okay, we move back to the original state. Now we are about to run e-core assembly instruction. Now at this moment, MPP field showed that the previous privilege mode is supervisor mode and current privilege mode is user mode. Now let me click step icon again to run e-core assembly instruction. Okay. Now please take a look at this. This icon is updated to user mode because previous privilege mode was user mode. Now this icon is also updated. We have the good question is now this feature, this information of status register can be available, can be visible using the TRACE32 debugger. Another important question is how to read the value of mstatus register as software level. That is a good question. So now I'm going to run another instruction to read the value of machine status register. I just click the step button to run another assembly instruction. Now it's about to run this assembly instruction. In the RISC-V architecture, we have CSRR instruction to read the value of the CSR register. Machine status register is one of the important CSR register in RISC-V architecture. If we run this instruction, the value of the machine status register will be updated to S1 register. Please take a look at this S1 register. In this instruction, S1 register is destination register. So let me go ahead. Please take a look at this. S1 register is updated to the value of machine status register. So let me just revert this instruction again. So here we go. Please pay attention to the value of S1 register. This is updated to this value. This value comes from this value. That is machine status register. Now, in this lecture, you get to know how the MPP bit field is updated when we run a code assembly instruction in the user mode. This is interesting observation. Now, let's continue another interesting debugging practice from supervisor mode to the machine mode in the next lecture.